This is a rate of work problem. And the way this works is um, you have to break it down by how fast they can work per unit. And this one's talking about they're doing it in minutes. The slower, you got a company that got two computers. The slower company can send all the emails in 40 minutes. That means that they can send or they can do if it takes them 40 minutes to do the entire job, then in 1 minute they can complete 1/40th of the job. And that's their rate of work. They can do the whole job in 40 minutes, or you can look at it as in 1 minute they'll get 1/40th of the job done. But then you have the second computer. So here's the first one, 40 minutes. The second computer can do the same job in 10 minutes, moving a lot faster. So they can get the whole job done in 10 minutes, or you can say their rate of work is 1 out of 10. They'll get 1/10 of the job done in 1 unit of time, in 1 minute. Now, if they work together, obviously they're going to get it done a lot faster. So I would expect my answer to be less than 10 minutes, and that's what we're looking for. But again, it has to be in terms of the rate in which it works. So it's going to be 1 out of X minutes. This is what I'm looking for. If both computers are working together, how long will it take them to do the job? So the first one's 1 out of 40, the second one's 1 out of 10. So if they work together, I'm looking for 1 out of what? And this is a rational equation. Now, to solve it for x, since you have an x in the denominator, you've got to get that out of the denominator, and I might as well get rid of all the denominators at the same time. So I'm going to multiply through by what I like to call the magic number, or in this case, the magic algebraic expression that will get rid of a 40, a 10, and an x all in one shot. You can only multiply by one thing and one thing only, and what you do to one side, you have to do the exact same thing to the other side. So I want to knock out 3 denominators with just one algebraic expression. And it's got to be something that is divisible by 40, is divisible by 10, and is divisible by x. And that would be a 40x. And what you do to one side, you got to do to the other. Now on the left side, I'm going to have to distribute. I'm going to have to take the 40x times the 1 over 40 plus the 40x times the 1 over 10. And that's going to equal on the other side the 40x times the 1 over x. And basically, all of these 40x's, I could literally put them over 1 and it would be the same thing. That just makes them look like a fraction so that in my next step, I can use the fact that I'm multiplying fractions here, so I can cross-cancel common factors. And that's what's going to knock out all of my fractions. The 40 here is going to knock out this 40, but you're still going to have this x times this 1, so x times 1 is just going to make that an x. On the next one here, this 10 will cancel into this 40 4 times. But I still have 4 times x times 1, so that's a 4x. And then over here, this x is going to cross cancel this x, but I'll still have 40 times 1, which is 40. And technically all my denominators are now ones, so I really don't need them. And now I'm just going to combine like terms. Remember, this x here is really a 1x, so 1x plus 4x adds up to 5x's. And then if you divide by 5, x is going to equal 40 divided by 5 is 8. And so working together, they can get the job done in 8 minutes. And I expected that because the faster computer working by himself did it in 10 minutes. But he now has some help, so it should take him less than 10 minutes. So my answer, 8 minutes, sounds reasonable.